Okay, so good morning, everyone. My name is David, and I will do today webinars. Thank you for coming in this lovely, very hot day. And today we're going to try to do the rotary table or turning table, and depends how do you want to call it. And this is what we're going to build. So we'll build a table with the operator, with the, in this case, 4 slots. And I will try to teach you, show you some tricks, how to do it. Maybe it won't be, let's say, the best possible way to do it, but I think it's fairly easy, and I think it's also rather universal. So you can easily change the logic here and be able to create a table that turns left or right with 4, 5, 6, 10 slot, with robot, with operator, and you can easily change it to whatever technology or whatever cell production cell you've got there. Yeah, so this is like, let's say, base framework. Okay, so it's a base framework, and you can then later like tailor it for your specific needs. Okay, so let's start. Okay, I will just move it out of the way. Okay, so let's start building this this rotary table. So we'll start with some shape. So some visual shape. So we have some cylinder, make it 2/2 meters. So a little bit bigger. Okay. Well, this is the first thing we're going to do. And now we're going to create, let's call them the slots that are on the table. Okay. So we're going to do the slots, and I will do the slots with the queues. So I will drag and drop the queue, and I will put it on top. Look where my mouse is, on the shape. So now the queue is a part of the shape. So I will lift this queue up, make it slightly smaller. Okay. This is one of our queue, maybe also thinner. Okay, so this is our first slot that we've just put on the table. So whenever table will rotate, the slot will also rotate with the table. Let's call it slot _1. Okay, and now I'm going to Ctrl+C and copy it. So I'm going to copy the slots so I can put them on the table. Okay. So click on the slot, Ctrl+C, click on the shape, and Ctrl+V. So now, as you can see, this slot is also part of the table. And also the naming is okay. So when I copy it, the name, the number, and the end just increment. So I have slot number 2, only for the first one. Oh, I didn't put this, sorry. I didn't click on the shape. So now slot 3, click on the shape, Ctrl+V, slot 4. Okay. I will lift this one up. Okay, so we have 4 slots on the table. So what would be the logic? So we'll have the operator. I will put the product on slot A. The table will rotate. Slot 2. But the table can only rotate if all of the processes on the table has been finished. So our assumption is, okay, operator is putting product here, the table rotates, but then the operator puts the second product on the second slot. But in the meantime, on the first slot, there is some kind of process. And I can only rotate the table. I can only rotate the table when all of the processes are finished. Okay, so let's go back to the base position. Okay. And now we have 4 slots. So let's add some queues, some operator. So maybe a little small, maybe a little bit smaller, these queues. We have some queues. some source for some product. So I will call it like buffer in. This I will call buffer out. I have two buffers and operator. In flight, and we will create the product. Let it be a little bit smaller, like 0.2/0.2. And here I will put inter arrival time 0. So I will assume that I always have the product ready to be put on my table. So reset run, 5 pieces is there. Okay, so now we need to create the logic. So we do it in the process flow. As before, there are many other ways to do it. I'm trying to show you the way I usually do it, because it's fairly easy. It's easy, scalable, and very flexible if you want to change something inside the table. Okay, so we'll start with some schedule source. And we'll start with some resource. In this case, our resource is going to be our table. So this shape, maybe let's also call it Rotary table. And reference. So this is our resource. So we're going to use this resource to have the address of the table. So then if we copy it later, we just change if you want to have multiple tables, you can just copy the logic and then change the reference to a different table. Okay, and let's call it Rotary. Okay, Rotary. So if I reset and run it, I have one token with the others. Okay, now the question is how to do it and how to do it for it to be scalable, because I can have one table with 2 positions, 3 positions, 5, 6, 10, 12, whatever. I can put on each slot 1 piece or 2 pieces. There's huge variability in this case. So in the previous webinar, when we did the pallet stacker, usually all of them are very similar. You just stack pallets. And here, each production line can have different technology, different table with different number of positions and different, of course, processes on each position. So we have to ensure that it is scalable, and we have to ensure that every process on every step or every slot needs to be finished. Okay, so in this case, we're going to use the run subflow. So we're going to use the run subflow. So I also put the start and finish. And we need to create as many tokens as I have positions on my table. So because I've put, so if I go to the tree, I've put all the slots on a table. I know that the token.rotary subnodes length, so the amount of subnodes from the total table, is the amount of slots. Yes. So in this case, the quantity is going to be token.rotary.subnodes.length. So now if I reset and run it, I will create 4 tokens, 1 token for each, and 1 token for each slot or each station. Now, where the problem is in this logic? The problem is that because it rotates, I need to know on which slot I am putting right now my product, because in the first cycle, he will put this product on slot number 1. Then the table rotates. So I need to put it on this one here on the slot number 2, and so on and so on. So in each cycle, operator will take the product and put it on a different slot. And then you have some stations. So for example, here, somewhere here can be some robot, and he will do some process on the product on this station. So let's say this area, let's say, is a station. And on this station, in each cycle, different slot with different product will enter this station. So you can think we have 4 slots and also have 4 stations. So this is the first station, so the first position, second station, second position, third station, and fourth station. And stations are fixed, so they're all at the same place, but the slots will rotate, and slots with the product will rotate through the stations. So we have to somehow write the logic to know which slot is on which station. Okay, so we have to track it. And in order to do this, we create on the source a label. Let's call it cycle counter, starting with 0. So I know which cycle it is. So I can calculate based on this value, which slot is on which station. So this is the cycle counter. So now, whenever I run the subflow here, I need to know which slot is on which station. So we'll create 2 labels here. One will be station number. And it's fairly easy. You just creation rank, because it's always a 4 station. So if I leave it like this and I reset and run it, you will see I have, this is the station number 1, station number 2, number 3, and number 4. But I also need to know which slot right now is at this station. So I need to know which slot. So if I reset and run, I need to have the pair of parameters. So I need to know, okay, that on station number 1, there is slot number 1. On station number 2, there is a slot number 2. 3, 3, 4, 4. It's the first iteration. But on the second iteration, when table will rotate, I need to create another set of tokens when I have station number 1 and slot number 2. 2, 3, 3, 4, and then station number 4, yes, slot number 1 or number 2, and so on. Yeah? So you need to work like this. Okay, so we need to create here an equation. So I can have this value. Okay, so let's go here. Here we need to write 1 line of code for it. And we need to ask us, okay, which slot is where? And we need to solve it in one equation. Okay, and we also want it to be universal. Yeah? So it have to work if I have 3 slots, 4 slots, 5 slots, 6 slots, and so on. Okay, so let's write it like this. So we need to choose our slot. So it's one of the subnodes of my table. Yes, and we use the creation rank here plus token dot cycle counter. And we see in a moment why we did this. And then we'll put everything in the bracket and put here the modulo of token Rotary dot subnodes dot length. Okay. Why we do it like this? So this is the rest from the dividing. So for example, if I divide by number of slots, I will have the values. Like if I have here value 2 divided by 4, so the rest is 2. And so in this case, this ensures me that I will have value from 0 to 3. 0 to 3 because 4 divided by 4 is modulo 4 by 4 is 0 because 4 divided by 4 equals 1 without the rest. So this is the base, but then we need to take into consideration that I don't want to have their 0 value. So here we'll put -1, so you can start with the 0. You can start with the 0, and then we'll put +1 in the end. So I can ensure that it's always iterate from 1 to 4, starting with the 1. So this is the equation that we're going to use. And let's check if this is working. I will go back here in a minute after we see if this is working. And of course, we'll just quickly save it, because you never know what will happen. Yeah? Okay. So it's saved. So let's try if this works. So if I reach and run right now, you will see I have station number 1, and it gives me the pointer to slot number 1 of this queue. 2, pointer to slot number 2, 3, 3, and 4, 4. So it works, at least for the first, let's say for the first iteration. Let's see if this will work for the second iteration. So if I put a delay here, for example, 30 seconds, and then I will have in the end, I need to have the cycle counter label +1. So my label cycle counter will be incremented by 1. And I will go back to this logic. Let's see if this will give me the correct values. So this is the first iteration. So 1, 1, it's okay. I click step to jump, and I have station number 1 is slot 2. So in this case, the situation is like this. So station 1 is here and slot 2. Station 2, slot 3. Okay, so it works. So it's correctly, I have correctly modeled the changing of these values. Okay, so we have the base. So again, why do it like this? I use modulo because I want it to work all the time. And I put here -1, so I can start with 0. So I have 0, for example, for the first token. 0 divided by 4 equals 0, but I don't want to have 0. I need to have +1 here. Yes, I need to have 1. For the second token, 2 minus 1 is 1, plus 0, 1, divided by 4, 4 divided by 1. So 1 divided by 4, the rest is 1, plus 1, 2. So the second slot, and so on, and so on. It should work for any number of slots, because token Rotary subnode length is a number of slots. Okay, so we have the base. We know the addresses, so we know how the slots and station numbers are changing. So now let's write the logic. Okay, we want to write the logic, and the logic can be different for each station number in this case. So we'll put here a decide to determine what will be the logic for each station. Okay, so I will put here, for example, connector by case, and the case is going to be my station number, and let's say 1 will go to 1 to the first, and the rest will go to the second connector for now. And so first station operator. So let's create the resource here. Let's call it OP. So we have this operator. So we have to acquire him, take him. Yes. And now this guy should travel. Now let's call him operator. So this guy, so the operator, show this buffer. Maybe to make it easier, I also create here two labels. So be in and be out. So this operators goes to token in. Then he needs to load the product. So our operator will load whatever is first on the in. Let's do it FIFO away. Then he will travel. So the operator will travel to the slot. Yeah, that's why we have the here. We did it as a pointer, the address of the slot itself. So now I can unload. So the operator can unload what he has in his hand onto the slot. We'll continue this in a moment. Let's see if this works. So if I reset and run it, you go pick it up and put it on the slot. Now we have the first issue. Right now, slot 1 is here. We have to set, let's say, the base position for a table. So we always wanted to know that we are starting at this position. This is so slot 1 is on station number 1. It will greatly reduce the complexity of it. So let's go to the table. Let's add some on reset trigger when we set the rotation of a table to be 0, 0, 0. Now, thanks to this, whatever was the last position, if we reset the model, then the table will rotate itself to this position. Okay, so now if we reset and run it, operator will go and take. But you can see it looks like this. Yeah, so because the slot is higher, he goes higher onto the slot. And we don't want this to be looking like this. So let's create some network nodes. Okay, this arrow is a little too big. So right click and decrease the arrow size. Well, now we have to connect every slot to this point because he will have the access to every slot from here and buffers and also the operators. Now, if we reset run, yes, you will see, for example, I will connect here, we'll tackle this issue in a moment. Yes, we'll go there. Okay, I don't want him to leave the network nodes. So I want him to stay exactly here. I will go to the operator and change the logic for him to do not travel offset. So I always want this operator to be on the node. So this way I can easily change the position where he will stay when he put the product on the slot. Next issue is the placement of this box from the slot. So the slot is on the box, but because the queue, so the slot 1, the queue has logic stuck inside and our product is bigger than the queue, he cannot position it inside the queue. So we change it on every queue. So we change it to be do nothing. Yes. And now if I reset and run it, it will be exactly at the slot. if you plan to put multiple product in a slot, then you can change it, for example, to stack vertically or horizontal, depending if you want to put one on the other, on one besides the other. Okay, it works. Okay. We have this logic. So this is the first slot. Okay, we have 3 other tokens there because we didn't yet build the logic for the other stations. So for now, for example, just let's put there some kind of delay. Let it be 30 seconds. So I've put there 30 seconds delay. So then after operator will finish and all of the station also finish, so 30 seconds, then let's say I should rotate this table. So let's create logic here. So we'll do the kinematics. I will create kinematics. Kinematics for an object is going to be our rotary. Then we'll apply kinematics to the rotary. It's going to be rotate. What degree? It's going to be 360 divided by the number of slots on a table. So token dot rotary subnodes length. And the speed of rotation, it depends. I will just put there, for example, 15 degrees per second. And then we'll finish the kinematics to finish this movement. Okay, so now we'll reset and run. Waiting 30 seconds for all the other stations to finish. I'll use the step. And now it rotates. But you can see token stays here. Why? Because on the release, I didn't specify what resource I want to release. I want to release my operator. So again, reset run, he will load. I will click step to jump to the next events. So now the table rotates. Operator will load the next slot. Table rotates. Next slot rotates. Next slot rotates. And then here's our first issue because he put the second product in the same slot. And our operator should first remove the product from the slot. And then after removing, go for a new product. So you have to modify the logic here. So if there is something on the slot, remove it first before putting new product on the rotary. Okay, so let's modify this logic. This is our second part. So first we need to check. You can decide if there is something there, or you could wait for event. It depends how do you want to do it. I will use, for example, decide. So I will use some conditional decide. So I will check if my token slot subnodes length is greater than 0. So if there is something on a table, on a slot. So if there is something on a slot, I should go to the slot, take whatever it is on the slot, and then go with it to my bout buffer, and then unload what I have to my bout buffer. So this is the logic. Travel load, travel unload. Then I need to recheck again, because maybe I have 2 products on the slot. So if there is nothing there, then I can go here. in this case, how we do it doesn't really matter. But in the other case, it does, because we have two options there. Because we need to check if I have something on the buffer. I didn't check it before. That's why if I put it like this, I have an error. Why? Because FlexSim assumes that operator is already there and this logic runs faster than the model. So this is first before the simulation. So when I run this logic, when token goes to this load, I still don't have product on the queue. Okay, I don't have product on the queue yet. So that's why we have to check, we have to change. It didn't work like this before because then he needs to travel, and after travels he check, and in this case, the product will have some time to be on the queue. Okay. So if we put here decide, so again, I will check with conditional decide if there is something on my B1 buffer. So subnodes length is greater than 0. If it is greater than 0, I will do the process here. Yes, I will do the, okay, go there. I can try put 2 or 1. Let's leave it at 1. If there is nothing here. And why this is important here? Because if I put the decide, I can have empty cycle on my Rotary table. And I usually don't want to do it. I want to always process something. So for example, if the operator before me like is late by 0.01 second, and I will check it and there's nothing there, I will leave the table slot empty. And I don't want to do it in this case. So in this case, instead of using the decide, I will use the wait for event. So I want the operator to wait. If there is nothing on the queue, I want to wait. So I want to stop the whole table if there is no product ready to be put on this table. So I wait for event. I will use here on content change, and on the buffer is going to be increased to or through value 1. And I will check this box to fire if initial value has been met. So if my token goes there, there's something on the table. Okay, I don't wait for the new entry, or I don't wait for the content change. I will just take it. And then I will do it like this. So this will ensure that I will always put something on the table. Of course, I can have some variation. Okay, for example, let's wait 5 seconds and then release token on the second destination. So if there is nothing for the 5 seconds, okay, I let him do the empty cycle, yes or no. It will depend on the logic, but it gives you a little bit of flexibility. How do you want to do it? Okay, so let's save it and let's reset and run it and see. So now this was passed because there's nothing on the slot. So first slot, second, third, fourth, and now the first slot is entering it again. So we take the product, bring the new one, put it, and then again, rotates. So we have, let's say we have the base logic here. Yeah. So you could say the framework is here. There are some, of course, key points. So we'll go through it in a moment. Okay, but the base logic is done. So if I recently run it, you can see it's always rotates. Everything seems fine here. Okay, usually we want to specify the cycle time per station. in this case. Yeah? So for example, we create some global table. It's going to be like station cycle times. Okay, let's say we have 4 stations, yeah, because we have 4 slots. It's going to be 10 seconds after some operator put something there. I know 25, 30, let's say 20. In this case, going to be some process time. So we'll have some delay here. So this delay is going to be just the value from the global table lookup, station cycle times, and labels station number for the rest of the station. And then we'll put there some delay. So after I unload operator will need to do some operations. Again, global table lookup, cycle times, station number, cron 1 is okay, and let it be busy. So now if I reset and run it, he will spend some time after loading the product on the slot to do some operations, prepare, measure something, or thing like this. You can put the same delay here in the unloading if you want to operator to spend some time when he unloads, when he takes the product from the slot. Now, how can we tailor this logic for our needs? So for example, if you want to do some kind of visualization for other processes, you can easily create another branch here. Let's be 2, 2, might be 3 or 3, 2, like this. And let's say you have, I know, the robot. Yeah, you have the robot on the station 2. It's our robot. It's here. So then we need to acquire this robot. This is the second station. And all the rest go to station number 3. And then we can do some movement for the robot to model something, to make some visualization. So let it be robot. I know, -2, 1. Let's see if we move correctly. No. So we have the robot here, maybe z a little bit higher, let's say 1.8. Yes. And let him do some operations. So what is it? So let's say it's lower, do something there, and then you go back. Just some simple visualization. 1.2. Reset run. We can do some better positioning, like -1.7, for example. And then after it, I will release the robot. Yeah, so you can easily add some visualization just for the station, or some, let's say, more sophisticated logic for determining the process time on the station. Yeah, it won't be an issue here. It's just up to you. So each branch, each connection can be different station, or you have just process time, just to want to model the process time, then you can just leave it as a default. So all the rest will go here. I think I've put it on the second station, yeah? And the second station is here. Yeah, it's here, it's the other way around. So it should be without the minus everywhere. What are we lacking here right now? So we should put here the D side to check if the part is even there. Yeah, because right now the robot will always make the movement, even if there is no part on the slot, but you can just do it with the D side. And usually just for the beginning, because our assumption was that we will always put the product on the table, so it will never be empty. Yeah? Okay, so this is the base. I think it's fairly easy to build. It's fairly easy to scale. Yeah? So for example, if you want to add some station, yeah, of course we need to add here some time, so like 30 seconds. If you want to add more station, you can just copy and paste. This is slot number 5. Of course, we need to rearrange them so they be more or less in the position. And now the lorry should work the same. It doesn't matter. It doesn't matter how many slots you have there. Okay, this is one. Yeah. So next thing is, okay, we want to add some, because I already see some questions. Yeah, one is from I think from Martin, and the question is that we would like to operator to do something, to do some processes when the table finishes. So right now you can see this guy, he's doing nothing, but he has some time, but he's doing nothing. So we want to make operator do something when he finishes his standard process. So for example, make him prepare some parts, make him do some other process. Yeah? And I think the easiest way to do it is just like this. So after he finishes, we can create a token here with some process here. Yeah. So we have some previous process for this guy. So after he finishes it, we create new token, and then we'll make this guy do something. He can go to other station. So I can operator, or we can just go here to buffer in, so he can be prepared for the next cycle. So it's operator. So this is the process that he will do just after he will finish the base process. So if I reset run, after he finishes the process, he will go to the buffer in, so he can be prepared. He can already take the parts. So in this way, we can make him do other stuff, other operations, when he finishes, when the table is still waiting for the process, or when he's still rotating. So we can prepare the guy. We can also do it here. This create token. So, okay, let him do some operations. In the meantime, when the table is rotating, so let's say he's pushing the buttons, table starts to rotate. And only when it starts to rotate, right, the operator will go to prepare some parts, so he doesn't need to do it before. So that, of course, it will be some reduction of the cycle time each time, because he will do something in the meantime. Okay? Okay, that was the question from Martin. Guys, if you have any other question, just write them, okay? And I will try to answer them on the go. Okay, so you have the operator, you have this here. Okay, now let's check. Okay, we want to put there two products. Yeah, so we want to put two products on a slot. Okay. So there are a lot of ways. Again, there are a lot of ways to do it. Maybe just move everything a little bit lower so I can create some space here. So this is the first process. And of course, I think the fastest way to do it, maybe not the best way, but the fastest way to do it. This will be working. Yeah, this will be working all the time, because I will unload it until it's empty. And here we can just copy it. So now he will load 2 parts per cycle. The first one and the second one. You don't see it, but there are 2 of them. Maybe I will change for a moment. I know, stack it vertically so I can reset and run it. First and the second. So it's usually the question is, how do you want to tailor it for your needs? So this is like typical changes. Yeah? So of course the number of slots and the number of products that you can put on the table. Okay. Oh, I can see one more questions. Okay, if you want to rotate it the other direction. Okay, so if you want to rotate it in the left or right, yeah, the only thing you need to change is in the apply kinematics, you can just put there minus. If you put there minus, then the table will rotate the other way. Yes, but if it rotates the other way, you will also need to rearrange the slots. Yeah, so the slots are matching the rotation. Yeah, so now, so for the second slot to be really second on the stage number 1. Yeah, so that's where you can make it so it should work, and now it works. Yeah. Oh yeah, not reachable because I didn't connect slot number 5 with the A connection. Do it here. Yeah, so it also would work. Yeah. So as you can see, it's fairly easy to mod, to change, to make it just for your needs. Okay. Okay. Do you guys have any other questions for this model? Okay, I see someone writing a question. Give me a sec. Okay, so how to make, the question is how to make it so we can put the product from table to table. Okay, so I think the question is, we have 2 tables, and then I know, maybe a robot or something, we take the product and take it from some slot and put it onto other table. Okay, so it shouldn't be that hard. Yes. I will show this, maybe I will change this robot. Yeah, so it'd be like, let's say logic inside the logic in this case. And here, for example, for this robot, you just put the logic to load. So you should have this logic copy and part of this logic like one level lower to have it there, or to create some extra processes. Yeah, because you can just, instead of this traveling, you can just make the robot to load and unload. Yes, you need to create here a label. Let's call it like slot new. So which slot is, let's say, a new slot for there. And then in this logic, in this logic here, when we put the slot counter, it should be the same, let's say, the same code here, but instead of this rotary, you should put there the other rotary, so the other table, and the same cycle counter, so the cycle counter for the other table. And then it should work. So then you can have multiple tables working like this. Okay, one more questions about some visualization. Okay, about some visualization. So the question is, what is the best way to create the, let's say, the visualization of assembly for this process? Okay, so maybe I will just go back to what it was, so we can do it. Okay, so the question is, we are putting here two products. Yeah, we are putting here two products, and then we want to like want to make the assembly. So we want to make the assembly, and then remove those products as one product. Okay. So in this case, we're going to do it like this. So let's say we'll create one more logic, one more station. So let's say case for the last station. Okay. So we'll do this for the last station. So in the last station, we'll also have some delay here. So this is going to be like ST5, so the last station. I will just change the logic for the rest to have the same. So I will stack vertically. So the question is, okay, we have two products, but somewhere in the station, so we'll do some assembly, yeah? And now these two products, let's say, became one product. So the operator should take them as one, okay? Because now when we will make the full circle, you take one piece first and the second piece up. So, and this is the logic for my fifth station. So this is the fifth station. And I want to like make an assembly. Yeah, of course, let's say there are two ways. You could destroy everything there. You could destroy everything there and then create something new there. So the new product, new shape or something. So you can destroy part number one. For example, let's do it. So I will destroy both parts. So it's going to be slot. First, yeah. And then create something new. Let it be the cylinder or something. If I reset run it, I have two products. Okay, here I need to check. I have error because there is nothing there. So I can only run this logic. Maybe do it like this properly. So I can only run this logic when there is something on the slot, slot dot subnodes dot length greater than 0. So if it's greater than 0, do it like this. If not, just go to finish. Okay, here. Yeah, I should create it on the token.slot. This is the issue. Yeah, so they will become the cylinder. Or you can just, if you want to, let's say, make an assembly of the other way, it's going to be not by creating something, but I will just move those objects into each other. So I will move slot dot subnode, in this case, second product, to my first product. But I will preserve the global position. So I preserve the global position. So now when I run it, nothing changed, but when the operator will take it, he will take two products at once, because this product is in fact inside this product from the tree perspective, and I preserve the global positioning, so they are positioned the same. And then you can just position the product on the slot, yeah, when you're putting them. So let's say if you want to be like this or the other way, you can change the position so they are positioned correctly. And then after you remove them from it, it's let's say it's one product. Yeah. So if you go here on the tree, here you will see the tree has only one box. Okay, there is box inside box, yeah, but you can handle them as a one piece, and the content of the queue is also one. Yeah, so then you can correctly model the movement, the logistics, and the other policies. Okay, 1 hour has passed. We finished the model. As you can see, it's fair. It could be simple, it could be complicated. It depends what kind of turning or rotary table you have on your line. But this framework is good. It's good. It's simple. It's easy to copy, easy to duplicate in your simulation. If you've done one table, you have done all of them virtually. So I don't see any more questions here in my chat. Okay, so I want to thank you all for attendance in this very hot time in the summer. And I hope we will meet again soon. And of course, if you have some ideas of what would you like for me to do with you on these webinars, just give us a call, write us an email, because this timetable was like, I think it was the most popular request to us, so we did it. So if you have an idea for new topics, just write us an email and we'll try to cover it next time.